Hi, everyone. I'm sorry, I needed to end our presentation a little early on Chapter 9, so I wanted to wrap up with the very end of the chapter and a couple more models that can be used for determining if you should move forward with a project for capital budgeting purposes. And I'm on page 295 of your book, and it's called the Modified Internal Rate of Return. So this model can be used to address some of the problems that happen with the internal rate of return when you have cash flows that are positive and negative, or you have mutually exclusive projects. There's several different ways of calculating a modified internal rate of return. But the basic idea is to modify the cash flows first and then calculate the internal rate of return using modified cash flows. So to illustrate, okay, so I'm just reading right out of the book. If you go back to the example where you have a negative 60, which is your investment, plus 155 and a negative 100. As we saw, there are two different internal rate of returns, a 25% and a 33.33%. So we next illustrate three different modified internal rate of returns, all of which would have the property that only one answer will result. So we'll eliminate that whole internal rate of return multiple ones. So first, the discounting approach. With the discounting approach, the idea is to discount all negative cash flows back to the present at the required return and add them to the initial cost. So the negative return here would be 100. We would want to determine its present value. So even if you're using your financial calculator, go to your apps, finance, time value of money, your N would be 2. Your required rate of return would be 20. Your future value, you could put in as negative 100. That'll give you a present value of $69.44. Add that to the $60 initial investment. Now solve for your internal rate of return. So I'm going to go back into my apps, finance. I'm going to go down all the way down to my IRR. I'm going to enter. Whoops, that's not what I wanted. Let me go back out, get totally out of there and clear. Go back in my apps, finance, IRR, enter. So now I'm going to put in negative 129.44, comma, do my second and bracket, 155, second bracket, close the parenthesis, and enter. And I get a IRR of 19.74%, 75. Okay, so you'll only have one positive cash flow. Another way is instead, and you could do this also to prove any reinvestment approach. So we compound all cash flows, both positive and negative, except the first, out to the end of the project's life, and then calculate the internal rate of return. So how much will there be in future value of the cash flows, not the initial investment? So the time one's cash flow of 155, determine its future value to the next year, which would be $186. That's positive. Subtract the second year's value of 100. So at the end of 2 periods, we will have $86. Okay, so that's the future value. So if we go into our apps, finance, use the time value of money solver, N is 2. Interest you're looking for. Present value, minus 60. Future value, 86. Go back up, alpha, enter. It's solving for a present value or future value. Finding the interest rate, 19.72%. So by modifying the cash flows, that will help us eliminate two separate interest rates as being the internal rate of return and give us a more precise amount. You could do a combination of the two. As the name suggests, the combination approach blends our first two methods. So negative cash flows are discounted back to the present and positive are compounded to the future. So if that's the case, we could still use our regular finance application here. N is 2. Present value is no longer negative 60, but negative 129.44. Future value will be the 186 because we never subtract the 100. Now go up and solve for I, and you get 19.87%. So no matter which approach you take when you have negative cash flow combined with positive, in order to find the internal rate of return, modify the cash flows, and then apply one of those three methods. The next area is called the Profitability Index, and this measures the benefit per unit cost based on the time value of money. What this means is when you have a profitability index of 1.1, it implies that for every dollar of investment, you'll create an additional 10 cents in value. And they talk about this at the bottom of page 296 into 297. So it's just another tool you can use. And it's defined as the present value of the future cash flows divided by the initial investment. And that's what you're doing here. $1.10 is your future cash flow. $1 is your present. So if you take $1 present value divided into your future cash flow, or which is sorry, I did that backwards. There we go. It's the $1.10, sorry, is the present value of the future cash flow. So in this case, you will be earning 10 cents. Take a look on page 296, bottom of the page. So if a project costs $200 and the present value of its future cash flow is $220, you're making a 10% return. Why? Because you're comparing present value of the cost of the investment to the present value of what you're going to receive in the future. So you're comparing apples to apples here. So this is very similar to the net present value. It's useful in situations in which we have limited capital. So the advantages are listed there, closely related to our NPV, and it generally leads to identical decisions. It's easy to understand and communicate, may be useful when available investment funds are limited, but it may lead to incorrect decisions in comparisons of mutually exclusive investments. So you have to be careful of that. So we should consider several investment criteria when making a decision. Just don't stick with one. Remember, the net present value and internal rate of return are the most commonly used primary investment criteria and probably some of the best, because it takes into account and answers with yeses those 4 questions we presented at the beginning. Payback is a commonly used secondary investment criteria. So just to review them one more time. Net present value is where we take the difference between the market value and cost. If the project's net present value is positive, then you will take on the project. So you take the difference between what the present value of the future cash flows are compared to the cost of it. This decision-making criteria doesn't have a lot of serious problems, and it's usually the preferred one. Internal rate of return is another. This is the discount rate or interest rate that makes your net present value 0. So you will compare this calculated rate to what you want the return to be on the project. If it's greater, then you're going to take on the project. It usually leads to the same decision as NPV with conventional, the same type of cash flows. Remember, positive. Internal rate of return, though, is unreliable when our cash flows become positive and negative. Remember, we use the modified internal rate of return then, or mutually exclusive projects, because it's not calculating the correct rate we saw with that crossover rate of the projects. The profitability index, this is a benefit to cost ratio. So we take the present value of those future cash flows divided by the cost. If that result is greater than 1, we take on the investment. It's hard to use to rank mutually exclusive projects. It may be used to rank them when there's capital rationing occurring, meaning we only have so much money for projects. Payback period, remember, isn't a really good method to use because it doesn't take into account any kind of present value, any kind of time value of money calculations. This is where we look at the length of time until we receive cash back on our initial investment. We usually pick some specified period and don't look at cash flows after that period of time. So if we don't get our money back by a certain period of time, we abandon it. So it's not a really great method. It's used for minor decision making. Discounted payback period, although isn't great, is better than just the payback period because now we discount those future cash flows back to present value and then see how long, based on the present value, we will recoup our initial investment. Again, you're comparing it, you're just picking an arbitrary period to cut off the investment. We saw many advantages and disadvantages. The average accounting return, we're not even looking at cash flow or time value of money. We're comparing an average profit to book value. So we usually look to see if this result exceeds some specified return. And it really does have a lot of serious problems just because of the factors that are being used to determine it. Okay, so just a quick review of those major methods we have to help us determine if we should take on a capital project. Remember, capital budgeting is one of the most important budgets created in the finance area. Okay, so post any questions you may have to the discussion boards.